We have discussed what are assertions in the verification environment and what are the different types of assertions, what are the advantages of assertions, exactly why do we need the assertions, how are it is making our job simpler by using assertions, all this we have discussed. So to summarize, what are the different types of assertions are immediate assertions and concurrent assertions. We have already gone through what are immediate assertions, what are concurrent assertions. So in however, to build an assertions, what exactly the building block of SVA are, either if you are creating some kind of requirement, you have to break it into some simpler Boolean expressions if it is possible. So then you have to create a sequence. Based on the complexity, you have to create a sequence. If it is a very simpler one, then you can directly use with the asset in the property itself, you can provide it. If it is very complex, you have to create a sequence where you will provide your set of statements and you will create a property and you will call that sequence in that property and then you have to assert the property. In coverage, how we have like a sample method, in the same way in assertions, the assert property should be there. Then only this your particular assertion will take an action on the particular environment. So, and you will always have the ability to, you should, the common practice is to have an ability to control the assertion. Means if when you want to on the assertions, you can on it, and when you can off the assertion, you should off it. In the coverage also, I told the same, right? All these things are the basic things which we need to keep it in our mind. So these are the things we have already discussed. And now let's see, we were actually going through the codes, right? So let us continue with that. I don't, some of them didn't join that day, the next session. So let me start with the first code itself because on that day I observed some couldn't concentrate or I don't know, I didn't get any responses from people. So let's start with that. So here here we can say that the assertions are included inside a module. So this is our stimulus basically. Whatever inputs we are providing, like this way, the different variables which we have here, that how it should behave. That stimulus we are providing in this initial block. And then we have created a sequence. For this simpler things, we actually doesn't need a sequence, but just for sake of the practice, they have written here like this a value as 1. So here it's like the label A1 and asset property of sequence 1. So whatever is there that we are passing it here. Through that we can check the current requirement. So let us run the same and observe the output. No. Let us see. We can see like we will observe the log what it is showing. Here it is telling like the assertion is failed at 25th nanosecond and 45 nanosecond, right? So 25 means this one, 45 means this one. And what is our assertion basically that we will see. The assertion is the at every positive of the clock, the A value should be high. Okay. So let us see why it is failing and how it is getting evaluated. So this is the positive of the clock, and here the A value is high. Okay. And then here it is positive of the clock, but A value is not high. So that's why it is showing the failure at the next positive clock. So here if it is showing its fail, it means that the before positive clock it is violating. So here if you see, and this passage of the clock, it is violating our assertion. So it is evaluating here saying that it is failed. The same thing would have happened here also. The 45, and you have to observe that it will not show whenever it is violating. It will see like when we have given it the passage of the clock, at that particular point only it will check. So at the passage of the clock only it will verify. If that is happening, the A is going low at this point, then it doesn't care about it, because whatever we have given is like the positive of the clock. Okay. So that's the main part here. At the position of the clock, here it is validated. So this is simple. So we can create some things like that. Means we can, for example, the same thing I will do like this. I think the syntax is not right. I will check this syntax and then we can try.
So, like, what might be the reason why the previous one we are getting
Voice is
violated?
very low.
Like, what might be the reason for that violation?
That is the stimulus which we have given. Wait, let me go back. Okay. So here, see, the stimulus what we have given is A value is high, and at 15 the A value is 0. So this way, as this is not some design, right? So we need to give some values to check whether our conditions are getting evaluated to true or not, right? So that's why we are providing randomly some values, okay? Or you can directly write $random of A if you don't want to give stimulus like this. Then now based on the random value, the A value get generated and then you can observe the output. Okay. For
So,
example,
at delay 15, if A equal to 1, then we will not get any error. If in case.
is it for everyone her voice is seeming very low or only to me?
Okay, can you hear me now?
Still the
Yeah,
same.
ma'am. Our voice is clear.
Okay, just a minute. Sudha, now you can go ahead.
I'm sorry. So at delay 15, if suppose if A equal to 1, then we will not have any error in the 25th delay at 25 nanoseconds. If
No,
in case if A equal to 1.
let us see. No, it won't be.
Okay. So basically assertions depend on the previous input then?
Not only previous input, basically it will depend like at positive of the clock, A value is 1, right? So I will observe that at the positive of the clock, whether the A value is 1 or not, that I will check. That the tool will check basically. If it is violating it, then at the next it will evaluate and give us the failure or passing case.
Okay.
Okay.
Okay. Thank you.
So that's how it is.
Hello.
Ma'am,
I'm
is
so
it
fast
concurrent?
and
Yes,
Ma'am, is it
Abhishek, go ahead.
concurrent or is immediate assertion?
This is concurrent assertion.
So that's why the output will came to the next cycle. Actually, immediate will.
Yes.
okay, ma'am. So for concurrent assertions, we will get after one clock cycle or
See, the evaluation will happen that way. Okay. If you see here, the evaluation, it is checking at the positive of the clock, and the evaluation it is giving me at the next clock cycle.
okay. After one clock cycle, right?
Yes, yes.
Evaluation,
Next
okay.
pause edge, basically.
Can you
Okay,
please
okay.
give me immediate and concurrent assertion between difference, ma'am?
Yeah, immediate assertions are assertions which we include those assertions in an procedural blocks actually. Now, always block, all those if we are writing the assertions, those are called immediate assertions. And the concurrent assertions are basically synchronized with clocks. Like with clocks, it will run. Means we will be writing an assertions reference to a clock. Means at this clock, this should happen this way. And after this, this A signal is high, After 2 clock cycles, the B should high. So we are taking the reference to the clock, and the things are evaluating at the further instances, not at the very immediate time. It won't it will not check. For example, in always block you are giving, in always at the rate you will have some sensitivity list, right? So based on whenever there is a change in that sensitivity list, the assertion will get triggered. But here it's not that case. Here he will be having some synchronization with clock. It will have a reference to the clock. Based on that, our assertions will work. So that is the main difference between the immediate assertion and concurrent assertion. So in the name itself, it is saying like the assertion will be triggered immediately. Right. Got it?
Yes, ma'am.
Okay.
Ma'am,
Yeah.
is it immediate assertion? Is it possible for controlling?
Controlling in the sense?
Whenever I want, for
So
example,
if
we are
you
taking a
have
call.
such kind of requirement, you can go with the concurrent assertions, right? Based on the requirement, you have to choose which kind of assertion you need.
Okay.
Okay. Okay, then so as Sudha, you told me, right? We can change it. If I change here, the assertion will not fail at 25 nanoseconds. So I have changed that, and at 25 nanosecond, the assertion is not failing. It is only showing
Yeah.
the assertion failure at 45 nanoseconds.
Yeah. Okay, ma'am.
Yeah. So we will see the other example. So here we have something like A or B, in the sense either A value should be high or B value should be high. At that point, the assertion will pass. Otherwise, the assertion will fail. Okay. So let us run this. So here, if you see in the log, it is failing at 25th nanosecond and 45 nanosecond. And it is also telling us the starting time. Okay. So here it is like just simple thing, no? Means A is high or B is high. So at whatever time it is checking, at that time only it is giving us the, means the failed case is giving us the same as start time. But usually there could be some scenarios like A after so many clock cycle delay. After so many clock cycles delay, we are trying to see whether B signal is high or not. This kind of things, the start time and end time also differs. We will see some examples like that. However, for now, we will see this. Either A should be high or B should be high, right? So here, if you see, and it is failing at 25 and 45, let us mark those so that it will be easy for you to analyze. So this is 25 and this is 45. At these 2 points, the assertion is failing now. However, at the positive of the clock, they are saying that whether A or B, in the sense, any of the signals should be high. It need not be that both the signals should be high. Whether A is high, also the assertion will pass, and B is high, also the assertion will pass. Okay, so here both are high. And if you see here, both are getting de-asserted. So it means this will fail here, but this will be evaluated where in the next posit of the clock. So at this posit, that is 25 is the time unit. That's why here it is failing. And the same thing will be happening in this stage also. That is at this clock cycle, A is 0 and B is also 0. A was 1 before and it was 0 here, and B was already 0. So neither of the case is happening, means neither A or B is high. That's why it is getting evaluated to false here at this instance. At this posit, it is evaluating. So this is the kind of assertion behavior will be. And then we will quickly see the other things. We have so many things in the assertions basically. We have different operators, we have different built-in methods, all those we can have a look. But before that, we will see
Hello.
this example, and then I will say like the clocks and all, how different ways we can take the clock. One thing is you let us check this example, and then we will get back to that. Okay.
Hello, ma'am. One question. Hello.
Yes.
Ma'am, in previous example, like we are getting failed message only. We will not
Okay.
get that assertion when assertion is getting passed. That message
No,
we will not get.
see, basically, we will have it by default statement like in AZ. See, now we didn't write anything, right? AZ property, that's it we have written. So in that case, it will only give the failure message if it is there. If it is failing, it has to, because it will check it every instance, right? So passing, failing, everything it is there, it is very confusing for us. So the failed will be by default will be there and it will get printed for us, the failed statements. So you can assume that whatever it is not showing, right, at that instances, our assertion is passing.
Okay, like ma'am, for every assertions, every type of assertion, we will get by default failed message only.
Yeah, if we haven't mentioned anything, then this is the way it will work.
Okay, okay. And I want to see pass message, then what I have to do?
Then you can customize your assertion in such a way. We will work on that also further.
Okay, okay. Okay.
Okay, and then this is the other assertion. I was telling, right, we can see now the operators come into the picture. So this is one of the operator, that is, we all know this hash is for the delay purpose, right? Likewise, in the assertions, we have like cycle delay operator, where we can provide the number of clock cycles. And suppose if I want to check the A signal is high and after the two clock cycles, the B should be high. So I can provide this way. This is one of the operator. You can also give ranges also. Means, for example, you can give the range window, like in coverage we have observed, right? We can give some range window. So 2 down to 4. Like this, if it is means either A should be high within this number of clock cycles, B should be high. It will check from 2, 3, and 4. So all these clock cycles, it should work. That way, that will be there, okay? So we can provide ranges also. And so now the clock, and there can be something like implication operator. Likewise, we have different things in the assertions. So now we will try to analyze this waveform once. Here, if you see, the assertion is failing at which nanosecond? That is 35 nanosecond. Means A is high after two clock cycle, B should be high. So you have to consider one more thing. So your assertion will get triggered only when A is high. Otherwise, your assertion will not enter to the further thing whether to check it is has to evaluate to pass or fail. So the first condition should be happening, and then only it will see like it should get a scenario where A signal is high, and after that only the B signal. If you want to verify like whether it is happening the same way or not, first let us analyze this and then we will make the other changes which we want to. So now it is telling it at 35 nanoseconds it is failing, right? Means this is the instance, okay? So it means here it is failing. The requirement is A should be high and after two clock cycles B should be high. And if you see here, the start time and end time will differ. If what is it? The start time is 15 nanoseconds. Means at this, the assertion is starting. At the 15th nanosecond, the A is high. So it means it will enter, it will try to evaluate the further part of the assertion also. And after two clock cycles, means this clock cycle and then this clock cycle, right? And after this, the B signal is high. So here it is high, the B signal. So then at the 35 nanosecond, it is showing the failure, right? A is high and after two clock signals, B is high. But why is it showing its failure? It is actually passing, right? I think this is showing for the previous thing. Here also there is a pause, right? So here A is high and then after two clock cycles, the B is not high. For this, it is evaluating here. But the start time it is mentioning as 15 nanoseconds, which is wrong. Which is the tool, why it is giving that, I don't know, but that's not the proper thing. At every POSIT it will check. So at this POSIT it is giving us error, but that's not the case. The error which is giving us here, that is because of this POSIT. At this POSIT also it will check, right? A is high. After this 2 clock cycles, the B should be high, but it is not high here. So that will be evaluated at this POSIT, and here it is giving us that error. And next again it will check here. It will check here when A is high, and then after 2 clock cycles the B is high. So it means at this 45 nanosecond there shouldn't be any failure. So you will not have any failure here. So that way things work. Is it clear for everyone?
No, ma'am.
Sorry?
No clarity, ma'am.
What is the clarity that you are missing?
Waveform analysis.
Okay, waveform analysis. What you haven't understood, tell me. Tell me from where you didn't understand. What about others, Sudha, Daman? Is it clear for you all?
Yes.
Abhishek?
I mean, it will check only at that point, like when A is high, and after 2 clock cycle, then B is high.
Correct, correct.
It will check that failing only that point, and it will be evaluated in
Next clock.
next clock cycle.
Yeah, correct.
Okay.
Okay, now Kiran, tell me what is the thing which you haven't understood. You analyze at your end for me, and you where are you stuck? You tell me, I'll help you out there.
Ma'am, actually simulation will start from 15 nanoseconds.
Why it will
I
start
think
from 15 nanosecond?
sure.
We have the
Translate.
positive 5 nanoseconds also, right? So it will start from 5 nanosecond also. It will start very.
So
Our simulation starts
how
at
can
0
we
nanosecond only, but the
how can we assume that?
Uh-huh.
How can we assume that?
What? How can we assume that? We have given like at the rate of POSIT clock, then we are
Yeah.
trying to check the assertion, right? Means we have given this way, no? Means in the sequence you have given at the rate of POSIT clock, and then you have given your requirement, whatever A after 2 clock cycles, B. So what is your first POSIT where it is starting? At the 0 it is starting, or 5 it is starting, or 15 it is starting? Where did you get your
Five.
first POSIT?
Five.
5, right? So that way you have to assume like it is working from there. Clear? Pick up when you have query, you can talk, right?
25th nanoseconds, is it pass or fail, ma'am?
You tell me what it could be, pass or fail.
I think pass.
Correct. See, at 25, is there any scenario first of all? At 5, it is starting, okay? At 5, when it is starting, A should be high. So A is high, so it means the session will start evaluating from here, means no, start triggering from here. Okay, then it will see when A is high, 2 clock cycle. After 2 clock cycles, B should be high. So this is 1 clock cycle, this is second clock cycle. And then the B should be high. B is not high here, right? So
But
this will
B should
fail,
be
but
low.
when it will show us the evaluation, at this POSIT it will show. So that's why here it is not showing, and here it is showing that it is failed. But actually, this is about this first one where we have started at the 5th nanosecond. The other thing is now at 15 nanosecond, again the assertion will trigger. So now A is high, After 2 clock cycles, B is also high, right? So when B is high
Yeah.
at the then at the next pause, that is 45. Here we don't have any failure. See, here we don't have any failure. It means that that second time when the assertion got triggered, that is passing.
Okay.
Clear? Okay.
Yeah.
So when
Yes.
it is getting trigger at that time, it will not show the message. Okay,
No.
when it will pass
Means
and
you mean to
failure.
say when it is getting triggered, here it is triggering like that. It should show that way. You are asking, no?
Okay, got it.
Okay. Fine. So this is about the different assertions examples. And the other thing is, first we will understand we have taken directly at the posage of clock here. Okay, there are different ways where you can take the clock. Means like either you can take in the sequence or you can directly take in the property like that. There are different ways. So where else we can take the clock in your understanding? Hello, is everyone there?
Yes, ma'am.
Yeah. So I mean to say here we have taken inside a sequence, right? Is there any way we can take the clock somewhere else also?
In the property we can take it.
Property.
Yeah, correct. So we can either declare the clock inside the sequence or you can create one more property like this. Okay. And here you can need not give anything. Okay, and here you can just declare the sequence, and here you can give like at the rate of posage clock. This is one way, and you can call your sequence. This is one way. The other way, what you can do is, so this is one way is directly you can provide the clock within the sequence. The second way is in sequence you will not provide anything and provide that in the property. The third way is you can directly give while doing the assert. Hello.
Ma'am, what is the third one?
The third way is directly you can do it when it is with the assert. Means this assert we are doing, right? Assert the property. You can give like at the rate of like this. At the rate of posage clock. You can provide the clock here. And then you can provide the particular property name here inside this. In property, you can call the sequence, and in here you can give that particular property name here. For example, property I have given some name called sequence 1. Okay, so that name you can give it here. This way also we can do. So there are 3 different ways, and one more way also you can do like using clocking block. You can declare the clocking block, and that particular clocking block you can use it here and try to access the variable. For example, like this also you can do. For example, some clocking block is defined already, and that clocking block name is suppose CB underscore M. Okay. So dot this particular sequence 1. So this property name is there, right? That you can access. This way also you can give. So these are the different ways in assertions how we provide the clock. Okay.
I mean here CV underscore. Hello.
CB underscore.
CV underscore M, it will showing that clocking block.
Yeah, for example, I have declared a clocking block here. Like this, I have declared a clocking block. And so this particular clocking block name is nothing but CB, right? Or CB underscore M. So this CB underscore M I can use and provide the clock to my assertion property. So this way also I can do. So these are the multiple ways how you can provide the clock to the assertions. Is it clear, everyone?
Yes,
And
ma'am.
clocking block is mainly used for interface for
Yes.
the synchronized
Yeah.
purpose.
Yes, correct.
And also, is it possible for skew? Where skew?
Yeah, in clocking block, you will always have a skew, right? Default skew will be there
Yes.
for input and output. And
Yeah,
if
yeah,
you
one
want to
unit.
change, yeah. So if you want to change it, you will change it in the interface. So whatever you will give based on a skew means what exactly? What do you mean by skew in the clocking block?
Before the sampling and after the results will get.
Yeah, means for input when the input has to be launched and output when it has to be sampled. So this is the things, right? So that will be using while in the waveforms, for example, how do I explain? So in this waveform is there, this is the clock is there. So there is a slight delays will be there. So the output where it is sampling. So that will be there in the interface itself. You will take the reference of the clock particularly. In interface, you have a clocking block. Inside that, you have declared one clock. Using that reference, if you want to use that in your exception, that is also possible. So that is one of the possibility basically. Instead of directly taking a clock, you can take the clock from there, or either you can do it from sequence, or you can do it from property, or you can directly give while doing the assert of that property. So this is how it will be there. So for your knowledge, I'm telling you like with the, how different ways we can provide the clock. If
Ma'am,
it's
if you
clear
don't
for
mind,
all
can
of you, I will move to the next thing. You
So
were telling
different
something?
way. Hello.
Yeah, Abhishek, go ahead.
Ma'am, so there are four ways to declare that assertion. So when we like which time we will use uh, one method.
Okay. See,
Like there are
it's a good question actually. So if you use anything can be done. There is no hard and fast rule that this is the way you have to do. But see, if you give the clock inside a sequence, so that will reduce your possibility to reuse it. Okay. For example, you have other requirement where you want to do it in a other way, means you want to do it something like negate or something. Okay, then if you provide a clock inside the sequence only, then it will be a problem, right? So instead, you can provide always the clock inside the property is a good method instead of providing it in sequence. In sequence, you just need to give your requirement like this has to happen, after this has to happen, this has to happen, that's it. So that sequence can be reused at any point of the time or any of the other modules or any assertions. If it is constrained in this way, it is hard coded basically, so you cannot reuse that particular sequence in any of the other things. So that is the main thing to use. So better I suggest that we can go for a property. Inside property we can take the clock. So this understanding if you have, it's always based on you, on whatever requirement is there, based on that you will choose which method you have to go for. If it is not necessary for reuse purpose, you can declare it in sequence. Likewise, you have to take up the decision. Okay, guys, everyone join the same session once again because the meeting will end within 1 minute. Okay. Let us start with the session. Where were we? Which is the thing that we have to choose the clock? Basically, it is for the reuse purpose. Based on that, you can take the decision, okay, like where the clock has to be declared, okay. So now let's move to the other things, okay.
And the clocking block syntax is clocking and clocking.
Here I didn't declare the entire
Here also say.
block. It will be inside interface. I just explained him when he asked like how it will be CBM. Okay. Try to understand the agenda of it.
No, ma'am. Actually, is it same for syntax assertions also?
Yeah, the clocking block will be declared inside the interface only. You are reusing that clocking block and giving it, right? Anywhere if it is a module, the syntax will be module and module only. Anywhere it is a program, the syntax will be same. Syntaxes will not change according to just the usage will change. Okay, so now let's see some more system functions provided by the assertion. So what are the assertions? Basically, you check the different kind of scenarios, right? So in SPA, it will provide us so many things like how it was like hash operator. Likewise, we have something like implication operator. In implication also overlapping, non-overlapping like that. So today we will cover some system functions which we have like dollar rose, dollar fell, all those we have. So those things we will cover. And tomorrow we will continue further. So these are some of the SVA inbuilt methods which are there. Just we need to understand its functionality. Based on that, we can use in our particular assertions. For example, this is one of the code which I have taken to understand dollar rows of A, for example. Dollar rows of A is nothing but, let me explain. So dollar rows of A means this is the clock cycle, right? So when we have some signal, suppose I have monitoring here the signal A, right? So it will observe like, do anyone know what is dollar rows already? So I can hear from you. Any guesses what it could be? From name or
Basically, rise
anything?
from 0 to 1.
Rising edge.
Yeah.
0 to 1.
Yes. Correct. So it means it will not check like at this posage clock, this is high or not. It will check like at this posage of clock, it is transitioning from 0 to 1 or not. So this transition will be evaluate is the basic agenda. If we want to, we have a requirement where you want to check this transition, then you can use this dollar rows. For example, in let us see in APB protocol or somewhere in a, I'm taking APP protocol because it is familiar by most of the people. That's why. So in that we have some three different phases. What ideal phase, setup phase, access phase. So for suppose I want to write an assertion to see whether the from ideal phase it is moving to the setup phase or not. So what is the thing that will happen is ideal to setup means there are some signals like P select or P enable, all these signals are there, right? Those transitions will be there. So in the ideal phase, the P enable will be 0 only, and means P select will be 0 only. But when it comes to setup phase, it should transition from 0 to high. So if I want to write an assertion whether it has entered to the setup phase or not, at that point I can write like dollar rows of P select. Okay, in that case, I can evaluate like, so I can see like it is happening. So, but it will check at every positive of clock, right? So based on the things, you have to cleverly write your assertion, whether it is necessary for the entire simulation or not. But here, only the check I want to do is only at the setup phase, right? So you can use some other properties like disable if and only if. Means you can write some condition where your assertion has to be triggered or not triggered. You can write something like disable if and only if. Let me write on Okay, first let us understand this dollar rows, then we will get back to that disable if and only if also. So, okay, so here wherever at the positive of the clock, it will see like A value should be transitioning from 0 to 1. At those cases, the assertion will pass, and the rest all cases, the assertion will fail. You can tell like here at the positive of the clock, A is high, right? But still assertion is failing. That is because it will check all, many will get confused with this. That's why I'm stressing out so much. It is like they will be telling like A is high here, but this doesn't check like that. This checks like the transition from 0 to 1. Only so this part of this only will get covered, then only the assertion will pass. Otherwise, it will fail. So, is there any scenario in this entire simulation where the A is going from 0 to high? Here it is, right? And then where else? Here it is. So these are the only two instances where it will work, the assertion will pass. It means there are more failing cases, no? So it's better to see what are the passing cases to analyze, right, from the log. So here we have something like 0 to high. It means at this posage, means at 35 there won't be any failure, and 85 there won't be any failure, if I am right. Let us check that is it happening so or not. See, 35 and 85 is not there. Rest all case it is failing. Is it clear for everyone? I need response from people.
Yes,
I
ma'am.
don't like calm.
I understood.
Yeah. Fine. And then the same thing we can have a look for dollar fell as well. Dollar fell means just a reverse. From 1 to 0 it will check. Can anyone quickly tell me where it might fail? First of all, tell me where this assertion will get triggered. Means this kind of scenario, dollar fell scenario, where it is. And next, tell me where it will fail. Who will try this?
So at 15,
Okay.
25, sorry, at 15
Hmm.
and 70.
Hmm.
Yeah, two cases.
Okay. And so where it will fail, basically? Or where it will pass, you tell me, instead of fail. This okay, tell me it's wrong also, that's fine.
At 20 and at 80.
Correct. Let us check the same in the simulation. Actually, it's not 20. I guess it should be 25. 25, right?
Yeah.
Tejas, you are the one who said 20, right? Why you said 20? Can I know? You considered the neg edge actually. You should consider the pause edge, correct?
Yes, ma'am.
Yeah, so that's why it is 25 and the other is 80. Is it 80? Actually, it's not. This is the scenario, okay? And then the posage is here. It is evaluating from high to low, right? So next, it will check at the posage. The posage means the 75, correct? So you will not have 25 and 75 basically. So if you wouldn't have considered the negative, you would have answered the correct thing because you understood the concept. Just that you considered it as negative. Is it clear for everyone? Sudha, is it clear for you?
Yeah, yes.
Okay.
I have one doubt. Like actually, fell is from 1 to 0 at
Huh.
posage.
Correct.
It will fail at those cases.
No. See, we have already observed in the previous examples also, right? Means it when it is high to low, what is our requirement here? We are checking like dollar fell of A. Means dollar fell of A means what? High to low. So that is one scenario. where this will pass actually. So when it is high to low, it means here it is happening and this pause it. So where it will evaluate in the next clock cycle, right? So means here it is passing. This is the scenario you triggered, but it will evaluate it next clock edge. So here it will be passing. So that's why the 25 nanosecond it is not failing. Here we all have all the failing cases. So the 25 nanosecond statement is missing because that is passing. The same thing is happening at here also. Here you said that the scenario will be at 70. So where is the next passage? Next immediate passage is this one, 75. So here it is showing that it is passing. So that's why you don't have the 75 nanosecond time stamp at the log. Clear?
Yeah, understood.
Yeah.
Yeah.
Okay, now we will see some more functions, that is dollar stable basically. So these things may seem very simple to you, but remember all these system functions, because in the complex assertions these are the things will make our see, to write this you have to write like at this clock is this should be high, after these many clock is this should be low. This way you need to write, right? So this system function make your job very easy. It will help us to trigger the transition things, everything. So you need not write such things there. You can directly use the system functions and simplify your assertions. So try to concentrate on these things. So then the dollar stable of A. Dollar stable of A in the sense the value should be stable. Before if it is 1 and here it is at the clock cycle it is 0. It means it is not stable. And if the previous cycle also is 1 and the current cycle also it is 1, it means that the current signal is stable. So this is how it will decide like whether the signal is stable or not. So if there are some applications where you want to see your signal is stable, there is a requirement that the signal should be stable for entire simulation until the other signal is high. So you can write that way, like when A is high, the next dollar stable of some other signal. So based on the A dependency, the other signal will check like whether the B is stable for that particular instances or not. So that's why first understand all the system functions, then start taking some problem statements and try to write an assertions for that. That is how you should learn any concept. So first get the full theoretical knowledge of it, and then try to take any statement, problem statement, and try to write your assertions by your own. Okay, this way, and don't go to the waveform first. First you analyze what kind of output might come, and then you go to the waveform. Just compare what your analysis was and what exactly is happening, and then you can see the log. So that way you have to create your learning. Okay, so now we have dollar stable. Dollar stable of A we have given, right? So it means that at this positive of clock, A is 1, and this positive of clock, the A value has changed. Means this assertion will fail here definitely. But where it will show at the next clock edge, positive, right? So it means that here this
25.
particular thing will fail. In the same way, if you see at this positive of clock, A value is high, and this positive of clock also, A value is high, means the value is stable. So at 45 nanosecond, there won't be any failure. It will be passing. See, the 45 is not there. Okay. And the same way, let us analyze here also. At this posage, it is high, and this posage also it is high. It means at 55, there won't be any failure. See, there is no failure. Likewise, so on you have to analyze, okay? And then we will see something like dollar past system function.
Excuse me, ma'am.
Yes. Go ahead.
Ma'am, for the dollar stable, ma'am, only one previous one clock cycle should be same
Correct.
as the present.
Yes.
Okay, ma'am. What if I need only previous two clock cycle is stable like that?
That is what I'm going to explain now. Dollar past, okay?
So dollar past means current cycle and the previous cycle, it should be the same value, right?
Correct.
Ma'am, hello.
And yes.
Dollar stable means like for previous clock cycle also same value.
It should be like the current cycle and previous cycle. Both should be same. Means either it can be 1 also, it can be 0 also. That's fine. But this value should not change its state from one state to the other state. It should be stable. In the name itself, it is telling, right? It's stable. Means there should not be any change in that particular value.
Okay.
Clear?
Ma'am, like how many clock cycles should remain stable?
One
Minimum
clock
one.
cycle. The previous clock cycle itself, it will check.
Okay.
Can I move to the next thing?
Sure, ma'am.
Yeah.
Yes, ma'am.
So the dollar past will give the value of the signals from its previous clock cycle. I can mention something like this dollar past of a comma 2. Okay, this way I can give. So what it will do is this will check like given at the given posage clock, the current signal is high for before 2 clock cycles or not. Likewise also it will check. So if it is, I can give like this basically. Or I can, if you are not sure like what it will return, you can print this value, means dollar past value. You can print in some variable and can observe that particular output, what it is giving. So based on that also, you can understand like what exactly it is returning. Okay. So now if I want to see like a comma 2, let me check this. I can give something like this also. So here, if you see, it is failing at 5, 15, 45, 95. It means that it is seeing, it will observe 2 clock cycles. Now here it won't have anything. Basically, let us try somewhere here. This is our posage as we are trying to observe the dollar past, right? So it's better somewhere here if we see. So a value is, it will check from this previous clock, 2 clock cycles I have given, no? So this clock edge also a value is high, this clock edge also a value is high. So it means that at this point, means at 55, there won't be any assertion failure. Correct, right? And for example, we will pick one failing case, 45. So here it is failing, correct? So it means we need to check somewhere here. Okay. But suppose I am assuming where it is starting also, but the starting I really don't believe it's correct. Okay, here we will see.
From 35.
We will see here. So at this point, the previous clock cycle is high, but that previous clock cycle, it is 0. It means the dollar past will not return us 1 because there is no, there is some change there, right? So that's why here it is failing at this particular 45. Okay. So these are the different system functions we have. So for whatever things I have explained, those things you guys go through. We will cover some more examples on assertions. Like first we will clear out all the system methods what are available. And then we will take in the last session, basically, we will take some problems and we will solve those. So we have 2 more days, tomorrow and day after tomorrow, right? So tomorrow maximum things I'll try to cover up whatever are there in the assertions, and day after tomorrow also for the half session we can cover, and the next half session we can discuss some Q&As, and if you have any queries so far in the entire workshop also we will do it. If possible, make that session at 8:30 or something and we will have a long session. if possible. If not, we will do the same thing.
Hello,
Yes.
ma'am. So for dollar past, like if I
Actually,
want to
can
check, so
we take it tomorrow? It's already 10:30, right? We will take it tomorrow.
ma'am, only one question regarding.